Hello and welcome to StudyKwik, your quick and easy source for aviation knowledge. Today we're going to explore something every pilot experiences, but not everyone fully understands: the principles of an airplane's climb. Let's start simple. In straight and level flight, an airplane is like a perfectly balanced scale. It experiences four main forces: lift, weight, thrust, and drag, which keep the aircraft stable. Lift pulls you upward, weight pulls you downward, thrust pushes you forward, and drag pulls you backward. When these four are in balance, the airplane flies straight and level without climbing or descending. Now, what happens when you start to climb? Most people imagine that lift has to increase a lot to make the airplane go up. But in reality, during a steady climb, the airplane is still in a form of balance, just tilted along the new flight path. Here's the important detail. In a climb, thrust and drag still act along the airplane's flight path. Lift still acts at a right angle to that path. Weight always points straight down toward the center of the Earth. But because your flight path is tilted, weight now has two components. One part still opposes lift, just like in level flight. The other part works against thrust, effectively adding to drag. This means that lift in a climb is actually slightly less than in level flight. The big change is in thrust, which needs to increase to support the climb. Since part of your weight is now acting backward along the flight path, your total drag increases. To maintain a climb, you need extra thrust to overcome this. That extra thrust is what we call excess thrust, and that's the real power behind your climb. Think of it like walking up an escalator, requiring more effort. On level ground, you just walk normally. On the escalator, you're fighting gravity pulling you backward. You need to push harder. That's your excess thrust. Now imagine a pure vertical climb, like a rocket. In that case, lift hardly matters at all. The only thing keeping you going up is thrust from the engines. While airplanes can't climb like rockets for long, this illustrates how important excess thrust is. But there's more to consider. The speed at which you climb matters. There are certain speed where the difference between thrust available from your engines and thrust required to overcome drag is the greatest. This is your best angle of climb speed. Flying at this speed lets you gain the most height in the shortest horizontal distance, perfect for clearing obstacles after takeoff. If you go faster than this speed, your thrust available begins to drop. For propeller aircraft, efficiency declines at higher speeds. At the same time, thrust required increases because drag rises. The sweet spot between these curves on the graph is your best climb angle. Understanding these principles isn't just academic, it makes you a better pilot. You'll know why your airplane behaves the way it does, why power settings matter, and how to make smarter decisions in different flight situations.